Hi, welcome to my kitchen. Today, I want to talk about baking bread and what I think about when I bake bread as a physicist. Um, so I'm chose to for this recipe that I'm going to show you. I've chosen the simplest possible recipe for baking bread because it illustrates some key points about it without complicating things by having too many interesting ingredients and having multiple ingredients or having one ingredient do multiple things. And so that's the point of this particular recipe. It's not the best recipe, and I'll make some comments about that throughout the video, but it illustrates some particular physical processes and some chemical processes that are going on when baking bread. So we've got just 5 ingredients. Uh, Bread flour. Okay, you can use all-purpose flour for this, but I find bread flour is the best. The difference between all-purpose flour and the different types of flour is that bread flour has the highest proportion of protein. Flour is mostly starch, about between 80 and 90% starch, with just a little bit of protein, about between 10 and 20% protein. That's the gluten that you talk about. Um, we also have, of course, the other primary ingredient is going to be some water. So I've got by volume a cup of flour and about half a cup of water. So 2 to 1 by volume, but it's really about 1 to 1 by mass, by weight, because flour is so much less dense than water. The minor ingredients we have is a little bit of salt, a little bit of baking soda, and some vinegar. As I've already said, the bulk of the bread is going to be flour. That's the primary ingredient, and we'll find out that that's where most of the weight of the bread comes from. Of course, the water is used to help mix the flour, and it's also important in baking and rising, and I'll talk about that when we get to the baking section. The minor ingredients, you can tell that they aren't part of the bulk because they're so small, right? The mass of them isn't going to change, but they have an outproportioned result because they affect how the bread bakes and also how it tastes. Okay, the primary response. So you would think that the primary thing about salt is that it adds to the taste and flavor. That's what we use salt for. But actually, it's got an important role when mixing the flour and making the gluten. So and I'll talk about that when we start to mix. Okay, so let's start mixing our ingredients. So I'm going to take, first thing I'm going to do is I want the salt, which is to mix in with the flour. So in order to do that, particularly since I'm using a coarse grained salt, I'm going to dissolve it in the water. So we're going to put it in the water and we're going to stir that up. Also, the baking soda and the baking and the vinegar are what in this recipe are going to provide me with the leavening, right? So in other recipes, in the yeast bread, you would use yeast to make gas bubbles and provide you with the lightness of the bread and bulk it up. In this case, I'm going to cheat. This is a quick bread. We're going to use baking soda and vinegar. Baking soda and vinegar, you may remember, does the volcano reaction, right? You mix those two together, they fuzz up and it boils up and comes out of the glass. But I don't want to mix those before I've got them into the flour. So I'm going to just start by putting the vinegar into here. And the reason we use vinegar is it's an acid. So anything that you would put in here, you could use, if you wanted, you could use lemon juice. Anything that's an acid. I'm going to take that and I'm going to use my mixing spoon to stir this up and try and dissolve the salt and the vinegar as best I can. So the salt is made up of 2 ions, sodium and chloride, right? And right now those 2 ions are interacting with the water and they're getting torn apart from each other, and they're mixing in with the water because water is also polar, has electric charges and breaks apart, likes to break apart those ions. And I'm going to take my baking soda and I'm going to mix it in here. And I'm just going to stir that around a little bit. So now I've got my 5 ingredients. 3 in this cup, in with the water, 2 in with the in the flour in this bowl here. So I'm going to start to mix these, and I've washed my hands previously, so I can. Being right-handed, I like to keep my one hand as I'm mixing these. I like to keep one hand clean while I start to mix this up with my other hand. So I use my right hand to mix this up. Try and keep my left hand clean. Add in a little more water. When bread dough is distinguished from, the dough in general is distinguished from batter in the percentage of water that's involved, right? So if a batter is much more liquidy, so you would get a more water than flour in a batter. For something like bread, you have more flour than water, at least by volume. So okay, this is mixing up pretty well. You can start to see this. I've still got lots of flour that hasn't been incorporated yet, so I'm going to slowly add more water. So what's happening now is in the flour, I've said that flour is protein and starch. So 2 things are happening with the water. First, the starch is starting to absorb the water, right? So one of the ways you can thicken things is by using cornstarch. You could use flour starch as well if you wanted to thicken things. And so the starch starts to absorb the water, and it starts to bulk up as it absorbs the water. The other thing that's happening in this dough, and these are all at the molecular level, right? This is all happening at the level of the proteins and the atoms, is that the molecules of protein, there are 2 different proteins in here that make up gluten, and I forget their names, but they're 2 different proteins that initially aren't mixed up together. They're in their separate groups. But as I start to put in the water and mix them up, they start to commingle. So they break up from their individual groups, they mix in with the water, and then they find each other. Also, they start to find the salt that's in there, the sodium and the chloride ions that are in there. And the sodium and the chloride ions, because they're charged, because they have electric charges, they like to break up the clumps of the 2 different proteins and then cross-link them. And it's the cross-linking that's important. So the gluten in the flour is what provides you with the structure of the bread that is going to be cross-linked and make a network. And so by kneading this, and notice that what I'm doing is I'm folding it over, and so I'm doubling that surface every time. So every time I knead it, I fold it over and push it in. This is a small lump. And so I'm going to continue working that just a little bit. I probably need to add a little more flour, and I'll do that. But by kneading these, I'm mixing those 2 different proteins together to form the gluten protein, the gluten network. And then the starch is going to be embedded in that network, and that's what's going to provide me with the bulk. So the gluten provides the structure, the starch in the flour provides the bulk. And so by kneading this, that's what you're doing, is you're forcing those 2 together. Okay, and this, from my experience, which is limited, feels pretty like a pretty good dough. And of course, experienced bread makers will have a sense of how wet or dry the dough that they like is, and they will get a feel for that and might add a little bit extra protein, a little bit extra of the flour, or a little bit extra water, depending on how thick or not thick this is. So, great. All right. What else is going on here right now that I haven't mentioned is I haven't talked about the baking soda and the vinegar, right? The baking soda and the vinegar are having a little party in there right now, and they're making carbon dioxide. And so there's little bubbles being formed inside that gluten network. And that gluten network is going to act like little balloons. So it's going to act like a whole bunch of little balloons, and they're going to catch that gas and start to puff up. And that's when you get the so-called proofing of the dough, right? So the dough proofs, it builds up these little bubbles inside its interior, and from that, you're going to get the so-called oven spring, or the rise in the oven when it starts to bake. Okay, so my oven is preheated to 450 degrees Fahrenheit, which is a little bit less than 250 degrees Celsius if you're working in the Celsius scale. Which, as a physicist, I like to work in the Celsius in the metric system. So Celsius is like that. For the record, a cup of something is about 250 grams or 250 milliliters rather, by volume. If it's water, it's 250 grams, because a gram is a milliliter of water. All right. So I've got my dough. I weighed my dough, and my total dough is about 250 grams, which is about the mass of the 1 cup of flour, which is very light, and the half a cup of water together. Okay, so together they were about 250 grams, so it's not surprising that when I mix them together, I get about 250 grams. Mass is conserved, unless you're having nuclear reactions, which I hope we're not having any nuclear reactions in this kitchen. All right, I'm putting a little bit of flour on my baking tray here, my baking pan. Some different people like to use different things. Some people will use and I'm just spreading the flour around, either a baking sheet, or I've got a bread stone here, but I haven't had great success with that. So I'm going to use, but I've had good success with this old baking pan that I happen to have lying around. So I'm going to use that. I'm going to place my dough right in the middle. I shape it in a particular, I'm just going to make a little round biscuit like that. And the one other trick that I know about but don't understand is I'm going to wet this down. And apparently putting a little bit of water on the outside helps make a good crust. And the one other trick, take a knife and just cut 2 lines in it. That way, this is going to rise. I hope this is going to rise. And as it rises, these 2 cuts I've made are going to give room for it to rise. They're going to, instead of breaking up the crust in random spots, they're going to break up they've said, I'm going to break the crust here and here, right? The outside grows, and it'll become, the outside will become bigger, and I've said, okay, break the crust here and here so that you become bigger. All right, and then I'm going to put this in the oven for about 15 minutes. And I'm going to set my timer here on my iPad for 15 minutes. All right, now what's happening in there? There's a couple of things that are happening. Obviously, it's heating up, and as part of that, what's starting to happen is the water in the dough is starting to evaporate. And as it evaporates, it leaves behind this structure that we've made of the gluten network that's tied together, along with the starch that is embedded in that gluten network. Also, as the water evaporates and makes steam, there are these little air pockets that were created by they're actually not air pockets, they're carbon dioxide pockets created by the vinegar and the baking soda. Those little pockets then get filled with the steam and they get blown up like a balloon because the steam is under pressure the hot steam is under pressure and it pushes those little gas pockets out and fills them up with more steam. And so that's what's going to cause the bread to rise. So all over this dough, we've got the baking soda and the vinegar has created these little minuscule pockets all over this dough, and all of those are being filled with steam right now. And the other thing that's happening is on the outside, you're getting this nice crust. It's a caramelization of it's a combination of a caramelization and something called the Maillard reaction. So the caramelization is when you break down the sugars in the starch. You don't break them down, but you start to melt them, and they become a little caramel. Like literally, that's what caramel is. It's melted sugar. But also the starch and the protein have started to react with each other, and those cause make a lot of flavor. It's the same type of flavor that you would get on the outside of a grilled steak. On the outside of a grilled steak, that browning is this so-called caramelization and the Maillard reaction together. So those are the things that are going on in this oven right now. So and we'll come back in a couple of minutes and see what we have when we're done. Okay, so about 15 minutes has gone by. Let's see what we've got. Remember my heat protection. So just to give you a sense of what this looks like. Whoop, there we go. So my cuts in the, I'm going to put this on another towel. It's pretty hot. Grab it this way. My cuts in the bread did not work out so well. So rather than expanding at the top and blowing those up, it actually blew up at the bottom here. So yeah, so it's blew up at the bottom here and kind of blew out. But still quite a nice loaf. I'm gonna get a mass on this. So the dough I put in was about 250 grams. And this is about 230 grams. So a little bit of mass was lost because that water evaporated out of the dough and into the oven. And I imagine as it cools, more water will evaporate. And so I'm gonna, well, actually, let's get ourselves a cutting board here. We'll cut this open. I'm going to cut it right down the middle. Do it British bake-off style. Just cut into that thing, right? A bit undercooked. First off, you can see the steam rising there, but also you can see all the nooks and crannies and holes, and caused by the steam evaporating into the dough and into the holes that were made by the baking soda and the vinegar. And so lovely, nice little roll to have with dinner. Right. There are, of course, some things you can do a little bit different with this recipe. The primary difference between what I usually do and this recipe is instead of using water, I use buttermilk And buttermilk will add more fat into this, so it gives it a little bit of a creamier texture, slippery texture. The other interesting thing about buttermilk is I can leave out the vinegar because buttermilk, being sour, is a little more acidic, is more acidic than just regular plain old water. I don't have to put the acid in because the acid in the buttermilk, the acidity of the buttermilk will interact with the baking soda, and that's what will cause the rise. So now we can try a piece. Ooh, it's still pretty hot. Ooh, look at those those big juicy holes in there. All right, that's mm, nothing like warm bread on a cold winter's day. All right, this is baking bread with a physicist.